Okay, very good. Is it new haircut, Ibrahim?
What?
When did you have your haircut?
Yesterday.
Yesterday. Oh, actually, I had my haircut 2 days ago. What a coincidence. All right, good. Good to see Ibrahim. You are there. Ignur and Al Akbar, Selin, Adilhan. Guys, last
Yes.
time we actually talked about volume, right? And we will continue this. And let's see how far we can go. And next week, next Thursday, you are going to have some kind of monthly test, let's say, that will be around maybe 15 or 20 questions. You have to answer the questions during the class time, okay? Just reminding you, today we will have class, next Monday we will have class, next Thursday you will have test. Guys, now let's continue if you're ready. So we were talking about the volume, right? As see, volume means how much our solid actually occupies, right, in the air, right? If you're talking about the container, how much water does it hold? If you're talking about the solids, how much space does it occupy in the air? That is what we are trying to calculate this. As you actually practice more and more problems, you will see that these are very, very important concepts for in our daily life situations. Ibrahim, let's start with you. Can you read this quickly? And after that, let's discuss. And today, now, we'll talk about how to find the volume of a cylinder. And after that, how to find the surface area of a cylinder and also total surface area of the cylinder and some other solids. Ibrahim, let's start with you. Let's listen to you. Read it.
We can form a cylinder solved
Cylindrical,
by
cylindrical,
cylindrical, sorry, solved by vertically and
vertically,
stacking at the what?
vertically stacking up a pile of 50-cent coins.
Send coins as shown in the figure, and this wait, my skin is black now. Oh yes, and this salt is called a right cylinder. Its cross sectional uh, area is a circle. Still peep. Wait,
Pipes, still pipes.
yes, the pipes. I can't see the screen. Wait, 1 minute. Okay, oil drums and many tin
Containers.
containers for liquids and canned food are all common examples of cylinders.
Ibrahim, when I teach, do you understand me? Or you don't understand much?
Yes, now I understand.
So why are you reading so slowly?
I don't know.
If you don't know, let me tell you why is it so, Ibrahim? Because you're not practicing much. You have to practice reading, you have to solve problems so that you get used to reading these words. Okay, Ibrahim, if you don't know, I'm telling you the reason, because you're not, I mean, I'm not blaming you. If you really want to improve, you have to practice, you have to read to yourself, okay? Because if you're reading that slow, that means that you need to improve your English, Ibrahim. That's why you should not be quiet. If possible, try to keep your camera on, try to ask some questions, okay? In this way, you can actually learn something. Otherwise, you just keep quiet and behind the screen and always keep your camera on, off. That's actually for everybody. Once again, I am just reminding you, okay, you cannot learn much. I can teach you, but if you do not ask questions, if you do not keep your cameras on, if you are not doing homework, okay, that is, I mean, you're just slowing down your improvement. And this is not a school math, as I told you. This is a kind of intensive mathematics course, and that's a kind of private tuition, right? We are just meeting twice a week, so that's a good opportunity to discuss anything. All right. So you're just keeping quiet. That's why I'm teaching here. So just this is one example to visualize a cylinder. As you see here, a stack of 50-cent coins, right? If you just stack a few coins and just placing on top of each, you will see something actually. We are just naming that solid as cylinder. As you see here, just cross-sectional area, right? If you just cut this, that means that if you just remove any coin and look at this from the top, what do you see? You see a circle, right? So that means the cross-sectional area of a cylinder is a circle. It says as steel pipes, right? In daily life, we have a lot of steel pipes that we use to, how to say, for gases or water, oil drums, and many tin containers for liquids and canned food are all common examples of cylinder. Now, if you go to supermarket, for example, usually fish, right? They are canned, right? Actually, those cans are cylindrical shapes because the bottom is circular shape, top is circular shape. Okay, and for example, also jars, for example, right, is a kind of, what is it, cylindrical shape. We can just store what, jam or kind of any sweet or dessert, whatever it is. Anyway, guys, as you see here, since the cross-sectional area of a cylinder is a circle, right? For a circle, we know how to find its area. What is the area of a circle? Area of the circle is pi r squared. And to find the volume of the cylinder, what is the volume of the cylinder? It is just base area times height. And what is the base area? Base area is pi r squared. And if you multiply the base area by height, we will get the volume of a cylinder. That is how we calculate the volume of a cylinder. İlknur, can you read this?
Yes, I can. For a cylinder, we can find its volume by applying the same method used in finding the volume of a right prism.
Okay, how do we calculate the volume of the prism? Right prism, we should find its base area. After that, we should multiply by height. So that is how we calculate the volume of the prism.
I can't.
Also, like this
I
for
can't.
cylinder, they have just told you to find the area. I mean,
I
sorry,
can't
not
hear
area.
you.
Volume. Guys, can you mute your microphone if there are people around you?
It's
Base
not
area,
mine.
that is pi r squared, and we should multiply this by height. Okay, that is the base radius. That is how we calculate the base area. How about the surface area of a cylinder? Surface area we mean the total surface area. Now, as you see on the right hand side, we have a cylinder. If you have an A4 size paper, if you just roll this, we can form a cylinder, right? And after that, if you unfold this, what we get? Actually, we get a rectangle, right? And the top, that's the top, right? And the bottom, top and bottoms are circles. Let's say of radius r. So what is the length of this rectangle? The length of this rectangle, it's just the circumference of the circle, right? So circumference of the circle is 2 pi r, and that's the height. As you see here, to find the total area, surface area, now we have two circles plus one rectangle. Okay, so let me change the color. And two circles, that is 2 times, what is the area of one circle? That is pi r squared. Plus, how about the rectangle? We know that it is length times width. Now, if you look at the picture, okay, we have 2 pi r squared. How about L times W? What is L? L is 2 pi r, right? So that is 2 pi r. And we should multiply by height. What is the height of the cylinder? That's equal to h. So that is the total surface area. Okay, we are not talking about only surface area. Because in the question it says that surface area, they have to mention clearly. We are talking about the curved surface area or the total surface area. So if you just say the total surface area, then we have to include the top and the bottom, right? So that is also here, I can just simplify this. That's easy to memorize this. As I see here, 2 pi r, 2 pi r. It's a common factor. If I just extract this 2 pi r from the first term, what is left? R is left. From the second one, that is h. So that is 2 pi r times r plus h. that gives us the total surface area of a cylinder. Ibrahim, do you understand?
No.
No.
Yes.
Yes or no?
No, no.
So you don't understand anything.
Understand, but no. All of them.
Okay. So now to make this more clear, let's solve the problem quickly. Adilhan, can you read example 8?
The diameter of the base of a right circular cylinder is 14 centimeters and its height is 10
Height
centimeters.
is height.
Height. Find the volume and surface area of the solid cylinder. Take pi equal 22 divided by 7.
Okay, 22 over 7, that is approximately equal to pi. So for pi, we are going to use this fraction because 22 over 7, what is 22 over 7? This 22 over 7 is exactly, if you actually divide this using your calculator, 22 over 7, that's equal to, okay. All right. All right, anyway, so that's equal to 3.1428, approximately equal to this. So here, what you have to know here is the diameter of the base of a right circular cylinder is 14 centimeters and its height is 10 centimeters. To solve this kind of questions, I mean geometric questions, you have to draw, right? Actually, that helps you to understand the problem. Here we are talking about a cylinder. Let's draw a cylinder here. That is our cylinder. Okay. And here it says that the diameter of the circular cylinder is 14 centimeters. So here we have the diameter, right? So that is diameter. We know that it is 2 radii, right? Because in the circle, right, the longest chord, that means that the chord that passes through the center, we call this diameter. This is R, this is R. So what is the diameter? Diameter is 2 radii. So that's given here, diameter, that's equal to 2 radii, that's equal to 14 centimeters. Okay. And also height is equal to 10 centimeters. And also height is given, it is 10 centimeters, right? So number 1 is find the volume, and number 2 is surface area of the surface area of the solid cylinder. Okay. So number 1, we are going to find it is volume. Okay. What is the volume? Volume is base area times height, right? And what is the base area? As you see here, the base of this cylinder is a circle, right? So how do you find the base area? That's equal to pi r squared, right? Times, how about here, where we have h. And after that, if you remember in chapter 5, we studied how to evaluate an algebraic expression, right? To evaluate the algebraic expression, we have to substitute the values of the variables into the expression, then evaluate this. So now equals, do we know pi? Here it's given, right? It says take pi as 22 over 7. So I'm going to substitute here 22 over 7 for pi times. Do we know r? Since 2r is equal to 14, from here, the radius of the base of this cylinder is, what is it? 7, because 2 times 7 is 14. So here we have 7 squared times, now we have height. Height is also given, that's equal to 10. So here we have 10. Now I have substituted the values of these variables into this formula. But next step is just we have to evaluate, right? How can I evaluate this? That's equal to 22 times 7 times, what is 7 squared? That is 7 times 7. And here we have 10. This 7, 7, it is gone, right? and 7 times 22, that's equal to 7 times 20, 140, 7 times 2, 14, that's equal to 154. And if you multiply this by 10, here we have 1540. All units are in centimeters, so here we have cm cube, right? Because we multiply by r squared by h, centimeter squared times centimeter, that's equal to centimeter cube. So the volume of the cylinder is 1540 centimeters cube. Now, before I continue, Celine, are you there?
Yes.
Celine, 1 liter is equal to how many cubic centimeters?
1 liter.
Yes.
I remember you said like the last lesson, but I don't remember.
1. 1,000, right? 1,000 cubic centimeters is equal to 1 liter. So Celine, can you change this into liters? But in the question, it doesn't say, okay, I want you to practice this. Can you convert this 1,540 cubic centimeters into liters? How do we convert this into liters?
So there's 1 liter, 500 milliliter, and for
No. What should I do here, Celine? If I want to
Can I
convert
say-
this 1,540 cubic centimeters into liters, what should I do here?
convert.
Divided by 1,000, right? As you see here,
Yes.
because 1,000 converting centimeter cube into liters, we have to divide, because here 1 cm cube is equal to, if you divide both sides by 1,000, here we have 1 over 1,000 liters. So to convert centimeter cube into liters, we have to divide it by 1,000. To convert liters into cubic centimeters, we have to multiply by 1,000. So if you divide this by 1,000, then here we have 1.54 liters.
140.
So that means that actually 1,540, actually that holds approximately 1.5 liters. Exactly 1.54 liters. Okay.
Yes.
Now, usually we have a glass jar, right? Glass jar or bottles, let's say. And if you just measure this, maybe their height is, what is it? Their height is 10 centimeters approximately. And also their radius is 5, not 5, it is 7 or something centimeters. If you have a glass bottle at home, 1 liter glass bottle, you can measure this. Maybe it's less than this. Anyway, guys, let's continue. How about, let me use, is somebody asking a question, or can I ask a question about homework? Actually, 2 questions. Okay, Celine, let's finish this. After that, I'll answer a question. Okay, Celine. So, number 2. So now we have to find the surface area. Let's say the surface area is S, right? If you remember this, what is the surface area? 2 pi r times r plus h. Now, actually, you don't have to memorize this. What is the total surface area? Top and bottom, that is 2 pi r squared, right? I can just write like this, 2 pi r squared plus, and if you just unfold the curved surface, right? It's like A4 size paper. If you just roll this, and after that, if you just open this, you will see a rectangle. How do you find the area of the rectangle? Length times width. Because the rectangle, right, the circular part actually, that represents the length of the rectangle. So that's here we have 2 pi r and times h. Okay. Now, if you want also, I can substitute here and evaluate this. Now from here, you can see that I'm just adding top and bottom plus the curved surface area. So 2 times, what is pi? We know pi, that is 22 over 7. 22 over 7 times, what is r? That is 7. Here we have 7 squared. Plus the second part is 2 times, what is pi? 22 over 7 times r. R equals 7 times h is equal to 10. Now again, as you see here in chapter 5, that's why we practice this. And every time you're going to see this, we have algebraic expression. How do I evaluate this? If the values of the variables are given, we have to substitute them into the expression or equation or formula. Then we have to calculate. Calculate means either you have to add them or multiply them together or divide something by something or subtract, whatever it is, that using 4 basic operations. Now, if I simplify this, here we have 2 times 22, it is 44, times 7 squared over 7, that's just equal to 7, right? Here I have 7. Plus, in the second part, is 7, 7 cancels each other. 2 times 22, that is 44, right? 44 times 10, here we have 440. Now, if you just multiply and then together, we have 44 times 7 plus, here we have 440, that's equal to, what is it? It is 17. Okay. Okay, 10, 17, 17 times 44. 17 times 44, that's equal to 748. 748 cm squared, right? It's the area. Okay, let me just change the marker. That is the answer to the first question. That's the volume of this cylinder, and that is the total surface area of the cylinder. Ibrahim, did you understand a little bit?
Yes.
Very good. Celine, I am listening to you now.
Can I present one for 1 second?
Should I allow you to share your screen?
Yes, just okay, never mind. Just
Okay.
for the 11th question.
If you can share your screen, I allow you to share your screen.
Okay, I will share then.
Okay.
I just wanted to ask a question about the homework.
Yes.
1 second. I think this. Do you see my screen?
Yeah, I can see it. Celine
I
has
wanted to
started
ask about
screen
this.
sharing. Okay.
I wanted to ask about this. I got this answer, but I don't know if this is correct. And also one question about the second slide. This one. Can you please explain?
Yes, I can see this. Example 2.
Yes.
Okay.
Because I got like this, like I calculate this semicircle and this semicircle and then calculated overall, and I got the same overall, like this two.
Are you talking about the area or perimeter?
Area, I think so.
Okay, so area. How did you do that? Say again.
I calculated this 2x multiplied by 142, then divided by 2, and the same for this one, and then I just got this one.
Why are you multiplying 2x by 2? Here, what is the radius of this one? What is the radius of the small circle? Radius is equal to x, right? And how about the radius of this circle? The radius is, let's say, capital R, or let's capital equals 2x, right? And how about the radius of this one? Let me just call this R1. This one is R2. And this is just R. It is 2x plus 4x, that's 6x, and half of it because 6x is the diameter. So that's equal to 3x, right? So now, what is the area of the shaded region, Celine? You need to calculate the area of big semicircle minus area of the smallest one minus the area of this middle, right? The medium size semicircle. Then you will get the area of the shaded region. So that is, what is the area of the big semicircle? That is 1/2 times pi times r squared. What is the radius of the big one? It is 3x squared minus area of the small one. It is 1 over 2, semicircle. That's 1 over 2 pi times, what is this radius? X. That is x squared minus the area of this middle size, right? That's again 1 over 2 times pi times, what is it? This radius? It is 2x. Here we have 2x squared. Now, if you simplify this, 1 over 2 pi, right? It's a common factor. Let me just keep this out. Here we have 1 over 2 pi here. And 3x squared, that's equal to 9x squared. Minus, here we have x squared. So x squared minus 4x squared, right? 2x squared is equal to 4x squared. Here we have 4x squared. 9 minus 1 minus 4, that's equal to 4, right? And 4 is the multiplied by 1 over 2, that is 2. So that's equal to 2 pi x squared. That is the area of the shaded region in terms of x and pi. Did you get this answer? Because here, Selen, it says that in terms of x and pi, you should not substitute 3.1424 pi. You have to express your answer in terms of x and pi. And also in SASMO, usually they ask this kind of questions because you are not allowed to use a calculator during the SASMO exam time. Okay?
Okay, I got it. And just the 11th.
How about the perimeter?
Oh. 1 second.
Okay, let's move on. Next question. Selin, any other question?
I wanted to ask about the 11th page, but it doesn't open.
Page
But
11,
thank
what
you.
exercise is it? Is it 9A?
11th page, 8E.
No, what exercise is it?
11th.
What exercise is it? Is it exercise 9A or 8B or what is
Oh,
it?
9A.
9A.
Yes,
Are you sure?
I think so, yes.
Okay. Let me open 9A then. Now, can you see my screen?
Yes, I do. Oh,
Okay.
not this one.
That's why I asked you. You said 9A. This is exercise 9A.
Maybe 8A.
8A.
Yes.
Can't you see that exercise? That's why actually I asked you, because that's the area form. It should be from 8.
The one
Are you
thing
sure
I think I
8A?
didn't.
Let's see 8A. Is it this one? Hello?
Yes. Can you go down?
No?
In my page. Okay, it opened in my. I can present.
Yeah, that's why you
Just
should
because-
look at the exercise. Tell me exactly. I'll just open that one. Okay, Selim, have a
Um,
look, and we'll let's continue after you find it, and I will open and.
Found it.
Huh?
I found it. It's like 8A, but level it said
Eight,
intensive mathematics level 1, 8A.
exercise 8A.
Yes,
What question?
chapter 8.
No. What question? Question number. Question 8A, 5, 8A, 6. What question?
11th.
11.
Mm-hmm.
Okay, I have just opened actually that exercise 8A. All right. Once again, all right, that is 8A, 4, 12, 11. Is it this question?
Oh, it's another. I don't know why it opens like
Oh,
this.
Stella, how come we cannot see that? That's why I organize everything very well. At the top of this exercises, we have the name, exercise 8A. Can you just screenshot that picture to me? Okay, share with me and we will discuss that question, okay?
Okay.
All right. All right, ladies and gentlemen, let's continue. Selen, send it to me. Then after that, when I get this, we will get back to the question. Adilhan, Ibrahim, and Nigar. Nigar, are you there?
Yes.
Okay, Nigar, can you read this question? And after that, explain to us, what does it mean? And also before you read it, let me also change this to 22/7, our pi. Okay, Nigar, read it.
Okay, example 9, volume and surface area of a cylinder. If water flows throughout a 36 millimeter diameter pipe at a rate of 3.
I can't hear you. Can you read again a bit nicely and clearly and louder, please?
If water flows throughout a 56 millimeter diameter pipe at a rate of 3, what volume of water is
Okay, Nigar, is your internet connection bad or why? Your voice is so low and I cannot hear you well. Anyway, guys, if you are hearing me well, volume and surface area of a cylinder. Another example. Actually, these are SASMO type questions, okay? You need to really practice. If you understand, it helps you a lot to understand other questions. If water flows through a 56 millimeter diameter pipe, as see here, we have a dash between 56 and mm. That means that we are talking about a pipe, right, whose diameter is 56 millimeters. And it says that at the rate of 3 meters per second. That means that suppose that actually if you just open, for example, you go to a kitchen, you go to your kitchen, okay, open the tap. The tap actually comes, right, the water inside the tap, right, it comes through the pipe, right? And what is the diameter of the pipe? It is very small. Maybe it is like 2 centimeters, maybe 3 centimeters, right? And if you just open this, okay, so it says that at the rate of 3 meters per second. That means actually here, it is very fast, right? Every second 3 meters, that means that maybe our pipe is small and the water pressure is so high. So it is flowing at very high speed. Anyway, that means that every second, if you just put something into the water, for example, in 1 second, that thing moves from this point to this point, okay? From point A to point B in 1 second, okay? Because this 3 meters per second means this, okay? So what volume of water in liters is discharged per minute? Okay, that means that in 1 minute, how much water is discharged from this pipe? It's like, okay, again, if you go to your kitchen, okay, and open the tap, and suppose that the water inside the pipe, inside the hose, okay, it is flowing at this rate. Okay, if you just put a kind of pail or bucket right under this tap, and if it is flowing at 3 meters per second, in 1 minute, how much water will be in your bucket? That's the question here. How do we answer this question? We need to find the volume of the water, right? As see here, the speed is 3 meters per second. To find the volume of the water in 1 minute, right? So what is the volume? Volume is actually, if I just multiply that cross-sectional area, right? And by this, we will get the volume, right? Because in 1 second, actually, it is flowing that much. So let me just find the volume in 1 second, right? In 1 second, 3 meters. So in 1 second, how much water is flowing? So that is a volume actually. That's equal to, it is 3 meters. That is 300 centimeters, right? And the radius is, as see here, radius of the cross-sectional area, that's equal to 2.8. Actually, it is 56, right? So that's 2.8 centimeters, because 56 millimeters is equal to 20, what is it? 5.6 centimeters. Because to convert millimeter into centimeter, we have to divide by 10. To convert centimeter into millimeter, we need to multiply by 10, right? Okay, so we know the radius. Now, what is the volume? We know that the volume is pi r squared times, here our height is length, right? So everything is in centimeters. Pi is 22/7 times, what is the radius? Radius is 2.8 centimeters. So that is 2.8 squared times, now we have length. What is the length? Length is 300 centimeters. So here we have 300 centimeters. So that is the amount of water that is flowing into your bucket in 1 second, right? Now, if I multiply this by, what is it? It says that how many minutes per minute? So just we should multiply this by 60, because in 1 minute we have 60 seconds. How do I simplify this? So that is 22/7 times 2.8 squared is 2.8 times 2.8 times, here we have 300. Now, if you divide this 2.8/7, that's equal to 0.4 equals, here we have 22 times 0.4 times 2.8 times 300. That's equal to 7,392 cm cube. Okay, so immediately I can change this into liters. How do we change cubic centimeters into liters? We have to divide it by 1,000. So that's equal to 7.392 liters. So that means if you just open the tap, the water is so a lot, in 1 second, that much water is flowing into your bucket. So actually that's the first step. The second step, actually I need to use purple. So we need to find the volume in 1 minute, right? Because the question says that what volume of water in liters is discharged per minute. Volume in 1 minute, let's say the volume in 1 minute, here, let me just use lowercase v. So here we have capital V. Capital V is equal to, in 1 minute means 60 seconds. 60. In 1 second, this much water is flowing, right? What is it? That is 7.392. This one is multiplied. So that's, if you just multiply this by, divide by 1,000 and multiply by 60. So that's equal to 443.52 liters. Okay. If the water is flowing at this rate, and if you just open it and put some kind of water, actually it is discharging this much water. How much? 443.52 liters of water, if you're talking about water. And usually, guys, where do we use it? See this? I don't know if Azerbaijan, when you're walking outside, for example, especially at night time, when I travel with my kids, usually, after 10 or 11, and the city is empty, no big traffic jam. So usually I just take them outside and travel, and after the walk and eat ice cream somewhere. As you see here, it's always hot. So I just see a kind of big tankers, they just travel, visit the gas stations, and they have to discharge, right, the gasoline or petrol into the big tank under the ground. So the ear pipes, it actually flows, the gasoline flows through the ear hose, maybe at this speed, it's so fast. And how do you calculate this? So you have to measure exactly, okay, if you know the rate, if I know the volume of the big tank, right, then I can know that, okay, after this many minutes, the tank will be full of petrol, so I can stop this. That's a kind of engineering question. Celine, did you understand this problem? If not, why? If yes, how much did you understand?
Yes, I did.
Ilknur, how about you?
I also did.
If you really understood, okay, after the class, maybe after a few hours, maybe tomorrow, don't look at the solution. Try to solve this one more time. If you really can solve and understand the problem, and that is a huge thing because you're going to see this a lot. Another question. Adilhan, let's listen to your beautiful voice again. Can you read this example?
Okay, the diagram shows a solid made up of a rectangular prism of length 32 centimeters by 12 centimeters by 18 centimeters and half, a cylinder with a diameter of 12 centimeters. Calculate the total surface area and also find the volume of the solid. Take pi for 3.142 and give your answer correct to one decimal place.
Okay. What is it? It looks like maybe kind of aquarium, right? Usually in big restaurants, I don't know, sometimes I see this kind of aquariums and they keep fish inside this glass aquarium, okay? So actually it's a kind of solid, right? It's a composite solid and we are just actually combining two solids. One is rectangular prism, as you see here, the first part, and the top one is semi or half a cylinder, right? We have a cylinder, it's just actually divided by actually bisected, or let's say divided into two parts, equal parts. That is a half cylinder. Okay, so calculate the total surface area. First, let's start with this question. Calculate the surface area, and after that they will find the volume. The volume is, I think, usually it is easier than finding the total surface area. So the first step, if that's our last question, let's see, if you have time, we will continue and try to answer Selin's question. Number one, we need to find the total surface area. Okay. So to find the total surface area or just surface area, all right, how do we calculate this? So that is a total surface area equals, I will start with the prism. Okay. So the prism, if you look at this side, the shaded region, right? And also opposite region, they are equal, right? They are identical because prism is like, now if you are sitting in your room, maybe your room has 4 walls, right? The 4 walls facing each other, they are identical. That means that they have the same area, right? So that's why I multiply this by 2. Okay, what is this area? That area is 12 times 18, right? That is the surface area. Okay, number one. So that is 12 times 18. Also, the other side is that rectangle. Now, how about this area? Let me just write here. How about this part? It's also rectangle, right? Actually, the length is 32 and the height is 18. And also the opposite side is the same, right? So here we have plus, here we have plus 32 times 18, right? It's done. And how about the bottom? But top is different, right? Top is like curved, right? It's half cylinder. That's why the bottom doesn't have a pair. So how about the bottom? The width is 12 and length is 32. Also, it's a rectangle, right? Only one. That is 12 times 32. Plus, now we need to find actually, what is it? The total surface area of the cylinder, right? And we know that the total surface area of the cylinder, let me just right at the top, what is it? Is 2 pi r squared plus, what is it? 2 pi r times h, right? But here we are talking about half cylinder, right? So I should actually divide this by 2. That is a total surface area. And that's why here, since it's half cylinder, I show it here 1 over 2 times 2 times pi. What is r? The radius is equal to, is it given? Here the diameter is 12 centimeters, right? So diameter is 12 centimeter means the radius is 6 centimeters. So that is 6 pi r squared plus 2 times pi times r, that is 6. And how about the height? Height is the length of this cylinder, right? This is actually a height. What is it? It is 32. So here we should multiply by 32. So that is the total surface area. Now, how do we calculate this? I can just using the calculator, we can do that because 3.142, that's why we have to calculate exactly. 2 times 12 times 18 plus 32 times 18 and the plus 12 times 32 plus 0.5 open bracket. It is 2 times pi times we have 36 and the plus 2 times 6 is 12. Okay, 12 times pi again times 32, close the bracket. If you assign the calculator, you can put everything together. The answer is 2684 point something. In the question, it says that leave your answer correct to 1 decimal place. So that's equal to 3. And it's the surface area. That's why the cm squared. Correct to 1 decimal place. Okay. That is a total surface area. Adil Han, may I ask this question? How do we calculate the volume of this solid? Just tell me the method. How do we do that? How would you do that? Usually solids, how do we calculate the volume? We need to find the cross-sectional area, right? And multiply by height. Is that right?
Yes. Yes.
So what's the cross-sectional area of this? It is semicircle and rectangle. Can you see that?
Oh, yes.
It is this one, right? Cross-sectional, if you just cut with a knife, what do you see here? We see here this semicircle, this one, plus we see this rectangle, right? That's the cross-section area. If I multiply this by length, right, we will get the volume. So the volume is equal to cross-sectional area. What is it? It is the area of the rectangle. It is 12 times 18 plus, and semicircle. What is the area of the semicircle? 1/2 times pi times r squared. And what is the radius of the circle? It is 6, right? Here we have 6 squared. So that is the cross-sectional area. So now if I multiply this by its height or its length here, because it's lying down on the ground, so that means that we should multiply by its length. Here we have 32. Okay, that's the volume. Now we have a calculator. We can use a calculator to calculate this. So 32 times 12 times 18 plus 0.5 times pi times, here we have 36, close the bracket. That's equal to 8721.55. Correct the 1 decimal place, it is 6 cm cube. Okay, we have 2 questions left, but I think, Celine, did you find your question?
I sent to you.
Okay, I got it. All right. Perimeter and area of simple figures. I think it should be from review questions. Hey, Celine, let's just look at your question. Okay, then I will finish the class. For this much is enough. Okay, that is review questions, Celine. Review questions 8. Okay. All right, Adil Han, can you see my screen now?
Yes.
What do you see? Can you read it?
Example 1.
Very good.
In the
So you can see it well.
ABCD.
Okay. So in this, actually, review questions 8. Celine, actually, if you practice all of these questions, that is a great job. And I think you must have improved a lot. These are really, really good questions and not so easy to solve, especially in SASMO, students struggle with geometry questions. Okay, so that is Celine's question, guys. That's the last question. Let's do this and finish today's class. So in this question, it says that the diagram shows 4 circles of equal radius touching each other. Okay, if the radius of each circle is 12 centimeters, calculate the area of the shaded region. Okay, calculate the area of the shaded region. Now, what do we see here? Actually, also, Sally, you can draw this with your hand so that you can see very well. Now, let's say what I mean here is if I just join their centers, and we will get a square here. Let's say this is the center of the first circle, that is the center of the second circle, and that is a center of the third circle, and this is the center of the the last circle. Now, if I join this, what we have here is passing through this touching point. It must, because that is actually perpendicular to each other. Okay, so what is the radius of the circle? Is 12, right? As you see here, this is the radius. So this one is 12. And also this one is 12. In similar way, that is 12. That's also 12. This is also 12. That's also 12, right? So now, what do we see there? We see, what is it? A square, right? Now, how do you find the area of the shaded region? Celine?
I think so.
Celine, just tell me, answer this question, Celine. Here, this
Yes.
part, okay, inside this part, only this part, not including the circle. How do we find the area of the shaded region? I just shaded with red. How do you find it?
I think this makes one circle.
So here, let me just write this area as A, okay? So that A is equal to the area of the square, right? One side of the square is 24. That is 24 squared. Minus, if I add this one, let me just write here. This one area is B. This area is B. This area is B. This area is B, right? So what is it? 4B. 4B is equal to, as I say here, B is just one quadrant, right? 4 quadrants together, they form one circle. So 4B is equal to just pi r squared. What is r? It is 12 squared. That's equal to 144 pi. That is the area of this A, okay? So now, so that's equal to 24 squared minus 4B, right? That's equal to 24 squared minus, what is 4B? 4B is 144 pi. 144 pi. Okay, so now how do you find the shaded region? Shaded region is A, right? A plus, what is it? This one is 4B, right? As you see here, the remaining shaded part is just one circle. So that is just one circle, is pi r squared. What is A? We have just found here, that is 24. 24 squared minus 144 pi. That is just shaded region. Minus, and here we have pi r squared. What is r squared? It is 144, right? 144 pi, because our r is 144. That is equal to 24 squared is 576 minus 144 pi. 144 pi. That is equal to 288 pi. Is something wrong here? Why? Actually, it is plus, right? No. I'm sorry.
Actually, I got 150 points.
It should be plus. It should be plus, because here it's plus, right? I wrote minus here. So 144 pi minus 144 pi plus 144 pi, that's equal to 576 cm squared.
Okay, thank you.
Okay.
Yes, I got it.
Okay, guys, thank you very much. Keep practicing these questions. As you practice more, as you understand more, you get more interested in math. As you get more interested, you will achieve more, okay? So everything as it starts with loving something. If you love it, you will learn a lot. If you don't love it, even it's the most important thing, you cannot learn anything. Thank you very much. I will see you on Monday, okay? Bye-bye, guys. Thank you.
Bye-bye.
Bye-bye. Thank you. Bye-bye.
Bye.